We just need the mole ratio from the balance calculation. So we get lots of mole ratios there. But normally we don't measure things in moles. Normally we measure things in mass. So here's the mole-to-mole conversion, moles of A to moles of B, whatever is given, whatever is wanted here. But there's no like mole meter. There's a mass meter called balance, where we can weigh things out. From the weight of things, we can figure out how many moles of molecules, how many moles of formula units we have, and then we can do a mole-to-mole, and then we can get a mass. So this is just basically grams of A to moles of A, moles of A to moles of B, moles of B to grams of B. This is the typical dimensional analysis stuff. And so let's take a look at a problem like this, where we do it. It's basically the same thing. We're going to ignore this here. We just look. This is grams of A to moles of A, moles of A to moles of B, moles of B to grams of B. We can also go to the number of molecules. So if we do grams of A to moles of A, we can go to from moles of A to the number of molecules of A, or the number of formula units. The same thing, we could do a mole to number conversion using Avogadro's number. That's what's shown here. Mole ratios here. What we need here to go from grams to moles is molar mass, and what we need to go from moles to grams is molar mass. So we'll be calculating a lot of molar masses for stoichiometry. So let's just look at an example here. How many milligrams of nickel 2 chloride are in a solution if 503 milligrams of silver chloride is precipitated in the reaction of silver nitrate and nickel 2 chloride solutions? So first, we need the balanced chemical equation. Let's go ahead and do that. Forward here. Let's see, put it in a piece of pen. All right. So we're going to reaction of silver nitrate. So what's the formula for silver nitrate? AgNO3. All nitrates are soluble. So that's the solution. And nickel 2 chloride. What's the formula for nickel 2 chloride? NiCl2. Good. If you look at this, what kind of reaction does this look like? Double replacement. And so we're going to get silver chloride. So what's the formula for silver chloride? AgCl, silver chloride, and nickel 2 nitrate. What's the formula for nickel 2 nitrate? Yeah, NiNO3 Good. All right, then we know that chlorides with silver are insoluble, so that's going to precipitate it. Now, nitrates with anything are soluble. So the driving force for this is precipitation. You see here. Well, if this is not balanced, we need to balance it. So we have one silver, one nitrate. We got 2 nitrates over there, so we'll need 2 silver nitrates here. That's going to give us 2 silver chlorides here. And that looks balanced here. So what we want is how many milligrams of nickel 2 chloride are in solution? 503 milligrams of silver chloride is precipitated. So what we have here is we have 503 milligrams of silver chloride, AgCl. And so what we're going to do is we want to get to this. And so we're going to go from milligrams to grams of silver chloride. And then from grams of silver chloride to moles of silver chloride. Once we're at moles of silver chloride, then that's here. We can relate it to any of these, because balanced chemical equation is just a mole ratio. And so they want us to say how many milligrams of nickel 2 chloride were required to precipitate it. So we'll go from moles of silver chloride to moles of nickel 2 chloride. And then from moles of nickel 2 chloride, we'll go to grams of nickel 2 chloride. And from grams of nickel 2 chloride, we'll go to milligrams of nickel 2 chloride. kind of the map that we're going to use here to do this. And so we just need conversion factors to put this all together. You know, basically we want to get everything to moles so we can do the mole-to-mole conversion here. But just use dimensional analysis to figure out what we'll need. So 503 milligrams of silver chloride. And then what we're going to do is we're going to get rid of the milligrams and go to grams. So there, we'll just use the definition. 1 gram per 1,000 milligrams. 1,000 milligrams in a gram. Okay, now we have grams of silver chloride. We need to get rid of grams of silver chloride. And we're going to use the molar mass to get rid of the grams of silver chloride. So we need to calculate the molar mass of silver chloride. So we'll need the periodic table for this. So let's go take a look. Periodic table. So look for silver here. It's hard to see probably from where you are. 107.87. 107.87. Oops. Silver. 107.87. Chlorine. Go over here. It's 35.45. This is not a great periodic table. Let me get a better one. 35.45. So we'll just add it up. These have bad resolution. So combining the masses here, 7 and 5 is 12, 9, 13, 8, 5, 13, 4, 143.32. Okay, we have 2 units for this. The 2 units would be grams per mole or U per formula unit. Well, here we're going to use grams per mole, 143.32 grams of silver chloride per mole. So if silver chloride is an ionic compound. So if I have a mole of these silver chloride formula units, that's going to weigh 143.32 grams. So this gives us the moles. Well, that's where we want to be, because once we're at moles of silver chloride, then we can relate it to any species in the equation. And so the question is asking for nickel-2 chloride. How much nickel-2 chloride do I need in order to form this much silver chloride? So I'm going to go to this. And I see that for every 2 moles of silver chloride, I need 1 mole of nickel chloride. So 1 mole of nickel-2 chloride is required for every 2 moles of silver chloride that's precipitated. So the silver chloride cancels, that leaves us with moles of nickel chloride. I know how much a mole of nickel chloride weighs based on molar mass. So let's take a look at nickel first. Give us better. Okay, I see nickel up here, 58.65. Nickel. 58.65 nickel. And then we have 2 chlorines. 2 at 35.45. 2 at 35.45, that gives us 70.90. So let's add them up. So you're going to have 5, 15, 9, 129.55 grams of nickel 2 chloride per mole. Now, nickel 2 chloride is also an ionic compound, so it's going to be a mole of formula units, not a mole of molecules. Okay, then we want it in milligrams. They're asking for milligrams, so we'll just convert it. 1,000 milligrams per gram. All right, we'll just make sure that the units work out, and then I can calculate the number here for this. So milligrams cancel, grams cancel, silver chloride cancels, moles of silver chloride, moles of nickel 2 chloride, grams. We're left with milligrams. That's correct. I have 1,000. I'm dividing by 1,000, multiplying by 1,000, so I can eliminate that. So let's see what we got here. Your book is doing this. I don't like to do this. Your book is going from milligrams to millimoles. I don't like to use millimoles, really. I just like to do the mole to mole. You can do whatever you want. It's up to you. I don't like to work with too many units. I like to convert them to the ones I like and then do it. So I like to do a mole to mole rather than millimole to millimole, but I'd say it's the same thing. Actually, I didn't calculate it, did I? Oh, let's calculate this. And so their setup is going to look a little different than my setup. But, I like to have the heart of this always the same, so it's always familiar, They're adjusting it, so if they're given milligrams, they do millimoles. If they're given micrograms, they do micromoles. I always just do mole-to-mole conversion. So I like it always the same. And so this is going to be 503 divided by 143.32 divided by 2. Times 129.55. 227.33. So 227.3. I'm allowed only 3 sig figs, so I'll just carry this. Milligrams of nickel 2 chloride required for 227 milligrams of nickel 2 chloride. So I just double check my calculations. That's what they got here, 227 milligrams. They're just doing a quick check, ballpark figure here. Ballpark check would be 500. These are about the same, so it's 500 divided by 2. Ballpark. 50 milligrams. All right, this is the amount that's required to do this. Do another stoichiometry problem. We'll do another standard stoichiometry problem before going on. Here. So if we have methane gas requires 2 moles. Each mole of methane requires 2 moles of O2. And that's going to produce, CO2 and water ratio. So first off, we need the balanced chemical equation. This would be the balanced chemical equation for this. And so this is a mole ratio, not a mass ratio. but, you know, a mole of methane weighs about 16 grams. A mole of O2 weighs about 32 grams, and we have 2 of them. So this is be about 16 grams of methane plus 64 grams of oxygen is going to produce, CO2 weighs about 44 grams. It's going to produce 44 grams of CO2. And water weighs about 18. So that's going to be 36 grams of water. And so for every 16 grams of methane, we produce about 44 grams of CO2. And so what we're going to do is, you know, that's a mass ratio, but, you know, the mole ratio is quite a bit different, you know, because for every mole of methane, we produce 1 mole of CO2. Well, they weigh different amounts. Like methane weighs a lot less than CO2. Hydrogen doesn't weigh that much. So the mass ratios are quite a bit different. And since we don't express these things in terms of mass ratios, then we're always thinking about moles. In terms of moles, 1-to-1 mole ratio between methane and CO2. So let's say I have 1 pound of methane. If I burn 1 pound of methane, how many pounds of CO2 are produced? Okay, now what I have to do is I need enough oxygen, because if there's not enough oxygen, then I'm not, you know, so I'm going to just say we're going to assume that there's plenty of oxygen, which there usually is. I mean, you burn it in air, so there's, you know, what we say is air, there's an excess of oxygen. You know? And so we're going to burn this methane in excess oxygen. If we burn this methane in excess oxygen, how much CO2 is produced? So this is to be the stoichiometry. So why don't you try this one and see. We would need one conversion factor. That is, there are 453.6 grams per pound. Do you remember that one? That one's going to be a given. You don't have to memorize that. How many sig figs is this conversion factor good to? This conversion factor is good to 4 sig figs. That's pretty much all you have to memorize it to. If you need it to more sig figs, then you just look it up. You know, 453.59237. And so tell me how many pounds of CO2 are produced for every pound of methane that's combusted. So why don't you go ahead and work on that problem.